In this video, we're going to try to solve 4 different sample quadratic equation problems by factoring. So let's take a look at this first example here. X squared plus 6x plus 0, x squared plus 6x equals 0, excuse me. When you're factoring, you want to try to find a term that is common to both of the terms in your quadratic equation. So here, both of the terms x squared and 6x have x in common. So we can take out an x. And in doing so, we have x times something equals 0. And what goes in this blank is x squared plus 6x divided by x. And you just have to look at each of the components separately. So x squared over x is just x, plus 6x over x is just 6. Now we have x times x plus 6 equals 0. And whenever you have a quadratic equation, you're going to have 2 solutions or 1 solution. In this case, we're going to have 2 solutions because x can either be 0, right? Because if x equals 0, then 0 times 6 is 0. Or you could have x plus 6 equals 0. Because if this is 0, then 0 times whatever x is will equal 0. And to solve for x and x plus 6 equals 0, we just need to subtract both sides by 6, and you're left with x equals negative 6. So your 2 solutions are just x equals 0 and x equals negative 6. So those are your 2 solutions for this quadratic equation. Now let's take a look at a slightly harder example. And so now we have to rehash our factoring skills. So when we have a quadratic equation, we're going to have 2 factors. Let me make this space a little larger. So you're going to have 2 factors. This will equal 0. And since the first term is 2x squared, you know one of the factors will have to have a 2x, the other will have to have an x, because the only way for you to have 2 terms multiplied to 2x squared is by having 2x and x, unless you have non-integer coefficients. And so 2x and x are your coefficients, and now your constant terms have to be 1 and 3, because 1 times 3 is the only way to multiply 2 integers and get 3. But you'll notice that this is minus 3, so we're going to have either plus 1 and then minus 3, or minus 3 and then plus 1, or any combination like that. So we're going to have to try to do a few factoring tricks. So we want the constant terms to be plus 1 and negative 3, or negative 3 and plus 1. So let's try to figure out what we need to do in order to get this. Well, you'll notice that here we can put plus 1, and then here we can put minus 3, because this way you have 2x times x, which is 2x squared, plus 2x times 1, which is 2x, minus 3x, which is minus x, minus 3 times 1, which is minus 3, and this equals right here. This is our quadratic equation. So the way to do this is you just have to experiment with different factors and find which one works out so that the factoring equals the quadratic equation. And now here we can just solve for x pretty easily. So either this equals 0 or this equals 0. In order for 2x minus 3 to equal 0, we need to have 2x equal, well, you can add 3 to both sides and you're just left with 2x equals 3, or x equals 3 halves. And in order for x plus 1 to equal 0, x, well, simply just has to be negative 1, because negative 1 plus 1 equals 0. And your 2 solutions are 3 halves and negative 1. And once again, we just factored from this original quadratic equation to get to a point where you can have 2 different factors, and then you're just having both equal to 0, and you're solving for x to figure out what your 2 solutions are. Let's take a look at this problem, where 9x squared minus 6x plus 1 equals 0. So let's try to factor. If you'll notice carefully, this is just a perfect square, right? Because you have 3x minus 1 times 3x minus 1. Because your 2 coefficients, they can either be x times 9x or 3x times 3x. And so let's just arbitrarily start with 3x and 3x. And then here, the constant terms, they either have to be plus 1 and plus 1, or minus 1 and minus 1. Because this middle term is negative, we know that this has to be minus 1 and minus 1. And by expanding this out, you have 3x times 3x, which is 9x squared, minus 3x plus 1, so minus 6x plus 1. So you'll know that 3x minus 1 squared is just equal to 9x squared minus 6x plus 1. And in this case, because it's a perfect square, you're going to only have one distinct solution. So since these are the same term, we know we only have to solve one of these linear equations. So 3x minus 1 equals 0. You add 1 to both sides, you're left with 3x equals 1. And so consequently, x has to equal 1/3. Here we have x squared plus 7x plus 6 equals 0. We can factor this out. We know that the linear terms will have to be x and x. And the constant terms, they can either be plus 2, plus 3, or plus 1, plus 6. You have to find a pair in order for the constant terms to add up to 7, right? That's the middle term. So the only way for that to happen is if you have plus 1 and plus 6. So you have plus 1 and then you have plus 6. And so those are your two factors. And you have x plus 6 equals 0. And x plus 1 equals 0. And you're left with x equals negative 6, or x is equal to negative 1. So these are your two different solutions for this particular quadratic equation.